بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will continue talking about exponential functions, and we are in fact in part 4. Let's see how do we deal with limits of exponential functions. Well, we have to memorize that the limit of ex as x tends to minus infinity is 0, and the limit of ex as x tends to plus infinity is plus infinity. And this is in fact very logical because e is about 2.7, and if we multiply 2.7 by itself infinitely many times, we get plus infinity. And for the first one, this is as if we have 2.7 to the power negative infinity, which is 1 over 2.7 to the power positive infinity, and the limit of this quantity tends to 0. So this should be memorized by heart. Remember, e to minus infinity is 0 and e to plus infinity is plus infinity. Remember also, in order to calculate a limit, we begin by substituting. We either get the answer or we get an indeterminate form. Now, in case we have infinity over infinity or 0 over 0, we apply L'Hopital's rule, and in case we have plus infinity minus infinity, we take a common factor, and finally, in case we have 0 times infinity, we apply the reciprocal method. So this is what we have to remember so far. The limit at minus infinity of ex is 0, and the limit at plus infinity of ex is plus infinity. And remember that if f of x is e to the power u, its derivative would be u prime eu. Now, the first example, we need to find each of the following limits. What is the limit of ex as x tends to 1? By substitution, we get e to the power 1, which is e. Now, the second case, the limit at 0 plus, if we just substitute, we get e to the power 0, which is 1 over 0 plus, and this is nothing but plus infinity. Now, the third case, at plus infinity, also by substitution, we get plus infinity, which is plus infinity. Now, this limit, as x tends to minus infinity by substitution also, remember e to minus infinity is 0, and this is negative infinity, so it becomes negative infinity. Part E, the limit of such a function at plus infinity. If we substitute, we get plus infinity over plus infinity, so we apply L'Hopital's rule. We derive the numerator alone and the denominator alone. The derivative of ex is ex itself, and the derivative of x is 1, and after substitution we get plus infinity. Now, in fact, this one could be memorized by heart. The limit of ex over x as x tends to plus infinity is plus infinity. Now, this limit, the limit of x over ex as x tends to plus infinity, also by substitution we get plus infinity over plus infinity. We can also apply L'Hopital's rule. Now, the derivative of x is 1, the derivative of ex is ex, and this becomes 1 over plus infinity, which is 0. Now, this could be also memorized by heart. Now, the limit of such a function at plus infinity, also we get plus infinity over plus infinity. We apply L'Hopital's rule. The derivative of ln x is 1 over x, and the derivative of ex is ex itself. And after we substitute, we get 0. Now, what is the limit of x minus ex as x tends to plus infinity? By substitution, we get plus infinity minus infinity, and in such a case, we take a common factor. Here, we either take x or ex as a common factor. Now, what I did here is that I took ex in common. I get x over ex minus 1. Remember, x over ex becomes such a fraction. Now, we apply L'Hopital's rule for this fraction. We get 1 over ex, and then after substitution, we get minus infinity. Now, this limit as x tends to minus infinity by substitution, e to the power minus infinity is 0, and this is negative infinity, so this is infinity times 0, so we apply the reciprocal method. Now the reciprocal in case of exponential functions is much more easier than the case of logarithmic functions, and this happens because if we want to put ex in the denominator, we just change the sign of the exponent and it becomes e minus ex. This is easier. And then we apply Hopital's rule. The derivative of x is 1 and the derivative of e minus x is minus e minus x. And after substitution, we get 0. Now, in fact, this limit could be also memorized by heart. So far, we can memorize 5 limits by heart, which are the limit of ex as x tends to minus infinity, which is 0. The limit of ex as x tends to plus infinity, which is plus infinity. The limit of ex over x as x tends to plus infinity, which is plus infinity. And the limit of x over ex as x tends to plus infinity, which is 0. And finally, the limit of ex as x tends to minus infinity, which is 0. Now let's see the application. This is the list that we have to remember so far. Okay, find each of the following limits. Try to do this one alone. Now here, if we substitute, we get plus infinity, and this is 0. Plus infinity times 0, we apply the reciprocal method. So e minus x becomes ex, then we apply Hopital's rule. We get 2 over ex, which is 2 over infinity, which is 0. Now try also to do this limit alone. Well, after we substitute, we get minus infinity over 0 plus, remember, e to the power x is always positive, so this becomes 0 plus, and the final answer is negative infinity. Now the third case, try also to do it alone. Well, if we substitute for this exponent, we get plus infinity minus 1. But here we can apply the leading term method because we have a polynomial here. So this would be nothing but the same limit of e to the power x squared. And if we substitute x by negative infinity, we get e to positive infinity, which is positive infinity. Now this limit as x tends to 0 minus, try also to do it alone. Well, if we substitute 1 over 0 minus tends to minus infinity, and e to minus infinity tends to 0. So this quantity tends to 0, and this is also 0, so the final answer is 0. Now let's see this miscellaneous question. We have the function f defined as follows. C is its representative curve. We need first to prove that the line y equals 1 is a horizontal asymptote to c at plus infinity. Try to do it alone. Well, in this case, we need to find the limit at plus infinity, and we expect the answer to be 1. Now, what is the limit of such a quantity? E to power minus infinity is 0, and this is 1, so the answer is 1. And from here, we can tell that y equals 1 is a horizontal asymptote. Now, we need the limit at minus infinity of f of x and the limit of this ratio. Try also to do it alone. Let's see the first part. When x tends to minus infinity, if we just substitute, we get e to the power plus infinity, which is plus infinity. This is the first part. And for the second part, the limit of this ratio, this is what we have. We apply Hopital's rule because we have infinity over infinity. We get minus e minus x over 1 by Hopital's rule, which is minus infinity. Now let's see the third application. This table is the table of variations of a function u. F and g are two functions that are defined on minus infinity plus infinity as f of x is e to the power u of x and the g of x is ln of u of x. Now the first question asks to determine the limit of f of x at minus infinity and at plus infinity. Try to do it alone and try to benefit from this table. Well, in order to find the limit at minus infinity of f of x, This is nothing but the limit of e to the power u as x tends to negative infinity. If we go back to the table, when x tends to minus infinity, u of x tends to 0. So we get here e to the power 0, just replace u by 0, which is 1. So the limit of f of x as x tends to negative infinity is 1. Now the limit at plus infinity, similarly, this would be the limit of e to the power u of x as x tends to plus infinity. And when x tends to plus infinity, we can see from the table that u of x tends to plus infinity also. So we get here e to the power plus infinity, which is plus infinity. Now let's see the second part. We need the limit of g of x as x tends to negative infinity and at positive infinity. Try also to do it alone. Well, if we work it out using the same strategy as part 1, what is the limit of g of x as x tends to minus infinity? It's the limit of ln u of x, and then when x is negative infinity, u of x tends to 0, so we get here ln 0 plus, which is negative infinity. And the last part, we need the limit of g of x as x tends to positive infinity. Similarly, this is the limit of ln u of x, and when x tends to plus infinity, u of x tends to plus infinity. So by substitution, we get ln of plus infinity, which is a plus infinity. Now, Rami or Amir, this is the table of u, and f of x in this case is 1 over u of x. The question is to determine the limit of f of x as x tends to minus infinity. Now let's see what's happening. Rami said that the limit at minus infinity of f of x is the limit of 1 over u of x, so he replaced f of x by 1 over u of x, and this is correct. And this is negative infinity because we have 1 over 0 minus. Now Amir states that the limit of f of x is the limit of 1 over u of x, similar to what Rami did before. And he states that this is a plus infinity because we have 1 over 0 plus. Now, do we have 1 over 0 minus or 1 over 0 plus? This is the only difference between the two answers. Well, when x tends to minus infinity, u of x tends to 0. And we can see from here, because after the 0, the function increases, we can state that this is a 0 plus and not 0 minus. So Rami's work is not correct and Amir's work is correct. Thank you.